Martian Barcode reveals hidden roll of dust. Avalanches. Martian Barcode reveals hidden roll of dust. Avalanches, a striking image captured by the European Space Agency's ESA ExoMars Trace Gas Orbiter on Christmas Eve 2023 resembles a barcode etched onto the reddish slopes of Mars. This unusual pattern, consisting of dark streaks cascading down Apollinaris Mons, an extinct volcano near the Martian equator, is actually the result of dust avalanches triggered by a meteoroid impact. Each slender trail, some mere yards wide and others spanning hundreds of yards across, reveals the path these fine particles took as they tumbled downslope following the disturbance. While these enigmatic slope streaks cover less than 0.1% of Mars' surface, their impact on the planet's climate is far greater than their size suggests. Scientists estimate that collectively, these avalanches move a volume of dust annually comparable to at least 2 global Martian dust storms. This makes them key players in shaping Mars' dusty atmosphere and weather patterns. A recent study led by Valentin Bickel from the University of Bern in Switzerland delves into the origins of these streaks. By meticulously analyzing over 2 million slope streaks across 90,000 orbital images of Mars taken between 2006 and 2024, primarily from NASA's Mars Reconnaissance Orbiter, Bickel revealed a surprising truth. Meteoroid impacts are not the primary culprit behind most of these dust cascades. Instead, his research suggests that seasonal shifts in wind and dust activity, rather than cosmic collisions, are responsible for sparking the vast majority of slope streaks. Meteoroid impacts and quakes appear to be locally distinct events, but on a global scale, they have a relatively insignificant influence, Bickel explains. To reach this conclusion, Bickel combined his extensive image analysis with data on global temperature variations, wind speeds, surface moisture levels, landslides, and dust devil activity. A sophisticated deep learning algorithm allowed him to pinpoint the precise time and location of streak formation across Mars, revealing clear seasonal trends in their appearance. The study's findings highlight a strong correlation between slope streak formation and Mars' dustiest seasons, particularly during the southern summer and autumn when winds reach sufficient strength to dislodge sand-sized particles. Sunrise and sunset hours appear particularly favorable for these events, though capturing images at these dimmer times remains challenging for orbiting spacecraft. The research also pinpoints 5 prominent hotspots for slope streaks across Mars' Amazonas Planitia, the region surrounding Olympus Mons, Tharsis, Arabia Terra, and Elysium Planitia areas characterized by steep slopes, loose dust deposits, and wind conditions conducive to triggering these cascading events. Understanding the mechanisms behind these small-scale dust avalanches contributes significantly to our comprehension of Mars' present-day climate system. As Colin Wilson, project scientist for the ExoMars Trace Gas Orbiter, notes, these observations could lead to a better understanding of what happens on Mars today.